Okay, this is 2006, and this is number 6. This is from Form A, of course. And this, again, is a BC problem. And we have this function given by the power series, so you should have that downloaded. You can download these from AP Central. And this is the general term of f of x. This is the general term of g of x, and these are a few terms they wrote out. Okay, for all real x for which the series converges, okay, this is g of x, and this is for all x for which the series converges, it's f of x. So first of all, they want you to find the interval of convergence for the power series for f. Justify your answer, so you want to show your work. So what I did was I checked it out, and it does go from n equals 1 to infinity. So I rewrote f of x in the general term, which was negative 1 to the n times x to the n over n plus 1. And we want to find the interval of convergence, so we do our standard method. First of all, use the ratio test and the absolute value. So we check for absolute convergence, which guarantees convergence. And that takes care of any of these negative signs that are floating around, or negative ones, I should say. So we take the limit a sub n plus 1 over a sub n, so that's our ratio. I'd write that down so they understand that you know what you're doing. This is the ratio test. You could even indicate the ratio test, but they see this ratio, they know. And that's going to be the limit as n approaches infinity of negative 1. And then every time I see an n, I put an n plus 1, n plus 1, n plus 1, and n plus 1, plus 1. And then I just took the reciprocal, so that's going to be n plus 1 on the top, and then negative 1. That goes on the bottom, goes on the top. Okay? All right. Then what I did was I took all the n's and brought those out in front, because that's what we're going to use for our limit, because we're just taking the limit as n. The other parts, well, we'll take a look at that in just a second. So I have my n plus 1, n plus 1, and this is n plus 2, and there's an n. And then I've got my x to the n times x to the first power. That's the same thing as x to the n plus 1. And I got my x to the n. So these cancel. And these are n's are always going to be positive, so I don't need to worry about putting this in the absolute value. Only this needs to be in the absolute value. So I've got this, and I multiply this out. N squared plus 2n plus 1, n squared plus 2n. And notice, both the same degree, so I look at the ratio of the coefficients, which is 1, so this limit goes to 1. So I end up with just 1 times the absolute value of x, and that equals L, and that converges when L is less than 1, so that converges when the absolute value of x is less than 1, or equivalently, x is between negative 1 and 1. So there's my interval convergence by the ratio test, except I've got to check the endpoints and see what happens at the endpoints. So let's check our endpoints, and we've done this many times. So at x equals negative 1, I just took my series as I wrote above, and I put a negative 1 there. But I can combine these. This is negative 1 times negative 1 to the n, which is just 1 to the n, which is 1. So that just top ends up being 1 over n plus 1. And this is easy to see, all right, that if I take the limit of this, that's just going to be 1. So that diverges by the nth term divergent test, because if a series converges, the limit of the nth term is equal to 0. So if the limit of the nth term is not equal to 0, it can't converge. So therefore, this is a divergent series. So we don't have a convergence at negative 1, x equals negative 1. Okay? Now let's try x equals 1. We'll put 1 in here. And we've got negative 1. Now this is just 1. So we're just going to have this alternating series. You may say, aha, an alternating series, and therefore it's going to converge. No. Because again, remember, an alternating series, the nth term has got to go to 0, and the nth term doesn't. It goes to 1. Now we can't really say the limit's equal to 1 because it's alternating, so it's oscillating between positive 1 and negative 1. Or it's oscillating between positive and negative this, whatever this is. So definitely it's not equal to 0, so therefore it also diverges by the nth term divergence test, because the limit is not equal to 0. Now in this case we knew what it was. In this case we don't know what it is, because it's alternating, but it doesn't matter. It's definitely not 0. Okay, because this isn't going to 0. Okay? So therefore, not at positive 1. So therefore the interval convergence is just what we started with. Okay? -1 to 1. Okay, so that's the first part. Okay, the second part, this is the tricky part. That's pretty much something that you know how to do. We've done enough of these. And if you get that much on most of these, you're in pretty good shape. Okay. The graph of f of x minus g of x passes through the point 0, -1. Find y prime of 0, y double prime of 0. Okay? All right, so this is my y, and this is f of x minus g of x. So I want to find y prime and y double prime of 0. Well, y prime is just the derivative of y, which by using the derivative of difference is the difference of the derivatives. I can take the derivative of that minus the derivative of that. Now, if I look at my function, my f of x, when I take the derivative of f of x, look over here, if you take the derivative of this is just going to be -1/2, and then 4 times 2 is 4x over 3 times x, and this is going to be 9x over 4 times x squared. We're going to have x's all the way out. So if I put x in here, all these will zero out except for the first term. So this is my derivative. I wrote a few terms of my derivative, just taking the derivative. But I didn't have to write very many because I know that all these successive terms after the first term have an x. So if I put a 0 in for x, they will all go away. So what's left is just -1/2. So that's f prime of 0, just -1/2. Same thing with g of x. I took the derivative, and if you go back and look at g of x, the derivative of 1 is 0. The derivative of -x over 2 factorial is just going to be -1 over 2 factorial, and then we'll have x's. So this is what I had. So this derivative is just going to be, well, this is going to be this, but I don't have to worry about the other ones because if I put a 0 in there, all those will zero out, and this is all I have left. So there's my f prime, and there's my f prime of 0, and there's my g prime of 0, and y prime of 0 equals f prime of 0 minus g prime of 0, which is -1/2 negative or minus -1/2, which is just 0. Okay, same thing with the second derivative. If I take the second derivative, I just take the derivative of this. This drops out, and I've got 4/3 x, okay, and minus 18x and a bunch of x terms. So therefore, if I put 0 in here, I'm just going to get 4/3. Now for this one, if I take the derivative, this becomes 0, and I just have 2 over 4 factorial. That becomes 1, and then I've got x terms over here, which will all, when I take the 0 of that, will drop out. So I just have 2 over 4 factorial. 2 over 4 factorial is 2 over 24, which reduces to be 1 over 12. So this is f double prime of 0, and this is g double prime of 0. So if I take y double prime of 0, the second derivative, that's just going to be f double prime of 0. Oops, let's get down over here. There we go. Alrighty, so this is going to be y double prime of 0 will just be f double prime of 0 minus g double prime of 0, which is 4/3 minus 1/12, which is 16/12 minus 1/12, which is 15/12, which is 5/4. All right. So now we did what they want. The last part, determine whether y has a relative minimum, relative maximum, or neither at x equals 0. Give a reason for your answer. So this will give you a reason. If I draw my y prime of 0 equals 0. Okay, I found that from above. Remember, y prime of 0 was 0. That's up here. Right there. Y prime of 0 is equal to 0. Okay, so therefore my first derivative is a critical point at x equals 0, because the derivative is 0. Okay? Now what's y double prime? Okay, y double prime of 0 is 5/4, which is greater than 0 at x equals 0. So y is concave up. So I drew my second derivative test, and I got my concave up. Well, if this is a critical point and this is concave up, what does it look like I'm going to have here? It looks like I'm going to have a relative minimum. Okay? So y is concave up. This is a critical point at x equals 0. So therefore, x equals 0 it's concave up, and that implies that x equals 0 is a relative minimum. Okay, that's by the second derivative test. Okay, by the second derivative test, for extrema. Okay, and you could write that down. By the second derivative test for extrema. Remember the second derivative test, we use the critical point and we check for concavity. And if we have a critical point, if it's concave up, it's a minimum. If it's concave down, it's a maximum. So we have a critical point, it's concave up, so therefore we have a relative minimum. Okay, so I hope that makes sense, okay? And you could probably put a little bit more rhetoric there just to play it safe, but I think that's enough right there, especially if you show these two derivative tests, okay? I hope those help. Good luck.